So back in 2001, I was attending IT college in the building right behind me. And one day, one of my fellow students taps me on the shoulder and says, "Look at this." And he shows me his laptop running Linux. And I said, "Is that a good idea? We're supposed to be running Windows NT at this school." And he said, "No problem." He clicked, and suddenly we were looking at Windows 98. And he clicked again, and we're back to Windows NT. So he explained that he was using a software called VMware, and that allowed him to create any number of software-based or virtual computers on one single physical computer. Now, in his mind, the value of this technology was for software testing. You could effectively test your code on any version of any operating system that you wanted to, and you could also reset your test bed back to zero in just a matter of seconds. Now, since then, virtualization has transformed how we manage industrial systems, both on the IT and OT sides of the fence. It's become a standard tool for managing things like system resources, hardware costs, backups, failovers, and even network security. You can even virtualize devices for data storage or for network access. But the real value of this technology became clear with the emergence of web-based hosting services like Microsoft Azure or Amazon Web Services. In fact, when most people talk about virtualization today, it's really synonymous with both virtualized computing and cloud-based systems. The next few minutes will be a primer for those who are new to all this, while hopefully providing the pros with a few things to consider in an ever-changing industrial landscape. The basics. In its simplest form, a virtualized system consists of a physical computer called a host that runs a program called a hypervisor. This program allocates resources like CPU, RAM, and network across however many virtual server instances, or VSIs, that you choose to create. Pros. Dividing up a powerful modern server lets you manage its resources more efficiently. Rather than using a whole computer to run one application, you can instantiate separate, smaller VSIs that can all run on one machine. In addition to reducing hardware and maintenance costs, this greatly reduces electrical usage and rack space. Cons: the obvious danger here is that the host computer is a single point of failure. Having multiple redundant VSIs on one machine is fine, but if the system's mission critical, you had better have more than one host. Now, there are infinite variations on virtualization, but here are some of the most common. One or more virtualized machines on premises, or prem. This is the scenario basically we just described. You own and operate one or more host computers on your site. You create and you run applications across the virtual server instances that you drop onto these hosts. The pros: each VSI can easily be backed up. Plus, since VSIs contain all of the server resources and other virtual components your application expects, you can move it to a new host more easily than moving between traditional servers. Cons: if your backed up application has issues, every VSI you deploy will too. When configuring your application, take the same care to record system settings like device IDs and IP addresses that you would on a traditional server. If these settings were auto-filled, you may never be able to find them again later. Knowledge transfer is critical. These backed up VSIs can stay around longer than the staff who created them. Make sure you capture as much as you can about their limitations and dependencies. Next, a complete dedicated virtualized system in the cloud. In this variation, you lease a physical server on a cloud platform like Azure or AWS that you completely control and share with no one. You remotely install and configure all the software that makes up your system, and the hosting company is just responsible for the health and uptime of the server itself. Pros: you have a giant company that is responsible for your system uptime. Plus, these companies offer very flexible leasing options. Cons: you are still responsible for setting up and maintaining all of your cloud assets. Also, this is not the place where everybody knows your name. It won't be the most personal experience, and you can't go see your hardware, even if there's a problem. Remember that while the big players rarely go down, they do, and have, gone down. Again, if your system's critical, you may want to spread your application across 2 hosting providers. Next, a complete shared virtualized system in the cloud. This is just like the previous example, except you share the physical servers with one or more other customers. The pros: it can be significantly cheaper than a dedicated system. Cons: You may find that your application is competing for system resources with other customers, resulting in poor performance or even loss of service. As with the previous example, a secondary provider is better for very important systems. Finally, a colo. A colo is a data center that rents out rack space to customers for their servers and network hardware. Once you drop off the hardware, the colo staff manages it for you. Pros: you can have a much more personal experience. And if there's a problem, you can actually go to site and check it out. Best of all, they manage your server hardware for you. Cons: they could go out of business or change business priorities. They may only have a small number of staff, and that staff may not typically be required to maintain zero downtime. Do your due diligence and don't be swayed by the number of banks they have as customers. Ensure that they have multiple ISPs, UPSs, and AB power providers. Now, many tout that they have 99.999% uptime. Check the fine print and do the math. This may still add up to more downtime per month than you can afford. And if they do go over, you may only get a refund of that month's hosting fee. A final thought: hackers and bad actors can spend months or even years quietly snooping around your network before they make their move. In recent years, companies like Dispel have begun using virtual servers to create dynamic network architectures that regularly change to prevent bad guys from mapping them. As big systems get bigger and small ones become more critical, virtualization will continue to play a valuable role in reducing costs and maintaining uptime. And yes, they are still great for testing code.